Hi everyone, this is Miss Zahra, and in this video we will discuss everything about earthquakes. So first off, we learned in previous module that the earth is actually broken into pieces, and these pieces have a name. These pieces that it's broken into are called plates. All along these edges of the plates where they come together, over here we can see this red lines, these have a name as well. We call them the plate boundaries. The plate boundaries are where the plates meet, and they are pushing each other, they are pulling on each other, and they are sliding past each other. And as they do this, they make earthquakes. We also get a lot of volcanoes here. This lesson is all about earthquakes. So where do we get these earthquakes? We get them along plate boundaries. So just a reminder of where we get earthquakes. Earthquakes are found along plate boundaries. So how can we ask this question in an exam? Well, I could give you a picture and ask you, where will we get earthquakes? Please remember that these numbers can be moved anywhere. So you need to be looking for the plate boundary, which is this blue line. So anywhere along this blue line, you are going to get earthquakes. Number 1 is not on a blue line. Number 4 is not on a blue line. And number 2 is not on a blue line. The only one on the line is number 3. So please look carefully at the picture, and anywhere on this line where you see on the plate boundary the number, that is where we will get an earthquake. So we get earthquakes along plate boundaries. Now let's talk about how the energy in the earthquakes move. Well, they move in waves, and these waves have two shapes. So the two waves are called seismic waves. Those are earthquake waves. And the earthquake waves can move in different directions. They can move back and forth. And if they move back and forth, we call them longitudinal. An easy way to remember this is if you look at it, it looks like long lines. And these long lines are moving back and forward. So our two long lines are going to move back and forward. They are called longitudinal. Our second one we can see is looking like a snake. And this word has s in it. And how does the letter s move? It moves up and it moves down. So this wave goes up and down. Transverse, like a snake, goes up and down. Longitudinal moves back and forth. Let's look at some properties of these two waves. So just a reminder, again, our longitudinal wave moves back and forward, back and forth. Longitudinal, back and forth. When we draw our wave, the different parts of the wave have names. If I measure from one area that is pushed together to another, how long it is, this line is called the wavelength. So what is wavelength? Wavelength is the line, this line, that tells me how long my wave is. So remember, it has a L in it for line. Wavelength is the line that measures how long my wave is. So where does it measure from? It measures from compression to compression. How can I remember this word? It's close. Close. Compression is close. Compression, you will see this word press because it's pushing. It's close and it's pushing, pressing together. Compression, it's pressed close together. Over here, I can see that it is far. Far is rarefaction. Far. You will see far in the middle of the word. Far. Far, where the wave is far from each other. This spelling will probably be provided to you in the exam paper. So just be able to identify the look of the word and how it's pronounced. Rarefaction is far. Compression is close. Wavelength is the length of the wave, how long my wave is. Now let's look at our second type of wave. This wave, remember, it moves up and down like a snake. So because it's like a snake, I call it transverse. It has lots of S's in it because it moves like a slithery snake up and down. Okay? Up and down. Sometimes they use the word perpendicular instead of up and down. Perpendicular, up and down. So these are the parts of my transverse wave. The top of my wave is like a little letter C. K, 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 K. K for crest. All of the tops of the wave called the crest. The bottom of the wave, under, is called my trough. Rough, trough. Rough, trough. Trough is the bottom of the wave. It's a small word with an ah. Crest is a small word with ka. So the top of my wave is called my crest. The bottom is called my trough. Now let's talk about the l lines. There are two long words with l in them. And the wave length is how long my wave is this way. Same like we measure here in the other wave. It's the same direction. You can see it's going in this direction. So my line this way is called wave length. You're going to look for wave length. What? Wave length. But amplitude is of my wave. So wavelength, how long my wave is. Amplitude, my height, how high my wave is. Going up or going down. So how long my wave is called amplitude. And we can remember it because I want an A in science. I want to go up to the top. I want to go up high and get an A+ in science. A for amplitude. Okay, so please practice these words and memorize the key words. You memorize longitudinal, back and forth. You will memorize compression, wavelength, rarefaction. And again, transverse, up and down or perpendicular, crest, trough, wavelength, amplitude. The only way you are going to be able to answer these questions is if you first learn the words. Once you know them, practice the questions. Okay, now let's talk about our writing question. The writing question is going to be about the parts of the wave, frequency and wavelength. We want to know, do you understand what is wavelength and frequency? Wavelength, remember we learned, is the line going this way. Now let's learn this word, frequency. Frequency means how many crests. So frequency can be high, it can be many, or it can be low. It can be less. Low means less, high means more. Okay, so you should know the word high, more, low, less. As we look at this picture, we can see they are moving at the same speed. One is not faster than the other, but the one on top has more. Over here we can see that we have 1, 2, 3, 4, 5, 6, 7, 8 crests. But on the bottom, I only have 1, 2, 3. So I have more crests. If I have more crests, I have higher frequency. This just means I have more energy and able to make more crests. This one has less crests, and that means it has less frequency. I have little energy. So the speed is the same, but the energy is different. The higher frequency means it can make more crests, it has more energy. Lower frequency just means that it can make less crests and it has little energy. Okay, so frequency is how many crests. Okay, so how can we compare wavelength? Over here, I can see that this wave is very short. It's small wave. The wavelength is small. Here, my wavelength is very long. So if I have a low frequency, I actually have a very long wavelength. And if I have a short wavelength, I have a high frequency. They're actually not the words you would match together. So over here, let's look at how we can compare wave A and wave B using the words frequency and wavelength. Okay, so frequency and wavelength. So let's look at wave A. Wave A, wavelength, remember, is this line from here to here, crest to crest. So over here, it is not a long line, it's very short. My wavelength is very short. But remember, frequency is how many crests. So I'm going to use the word high or low. Let's look how many crests I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have so many. I have a high frequency, right? High frequency because I have many crests. So therefore, I have a high frequency. My wavelength is very short. So I have a short wavelength. So over here, I can say that wave A has high frequency and short wavelength. Let's talk about wave B. Same words. You see here that it is long, so I have a long wavelength. So if I'm talking about wavelength, I have a long wavelength, but I have very few crests. So I have a low frequency. So please remember to use these words. If you see many crests, we have high frequency. If I see less crests, I have low frequency. If the line from the crest to the crest is very short, I have a short wavelength. And if it is very long, I have a long wavelength. This will be a writing question. Now let's look at how we can analyze data from a table. If you are given a table, this isn't something you can study for. You have to think and use your mind. It depends what they ask you. So we need to understand the question words. They may ask you how many. How many means a number. I'm going to count, right? So how many I want you to count. How many earthquakes are, for example, more than? More than means a bigger number. More than what? More than 6 maybe. Now I will look for the number 6 and I will count all the ones bigger than the number 6. Okay, so I have 6. I will not count 6. Anything bigger than 6. 6.7 is bigger than 6. 7.3 is bigger than 6. 6.9 is bigger than 6. 6.2 is bigger than 6. 7.2 is bigger than 6. 7.2 is bigger than 6. How many is that? 1, 2, 3, 4, 5, 6. My answer is 6. If I changed this number, let's try again. How many earthquakes are more than 7? Now I will count. Where do I see 7? I see 7.2. Anything less than 7, like 6, does not count. This one, 7.2, bigger than 7. 7.3, bigger than 7. I have 1, 2, 3. Okay, so do you see? You will look at this number. If you see how many, we're going to count. If I see more than, I'm going to count bigger than this number. Now, what if they change this question and they ask me a different way? They ask me to count less than. So if they say how many earthquakes less than, for little, smaller than, okay? If they say less than, for example, 6.9, I'm going to look 6.9. Okay, I will not count 6.9. I want anything smaller than this. Smaller than 6.9. 7 is bigger. So all the ones bigger than 6.9, I'm going to take it away. So now I'm left with 3 numbers, 6.2, 6.7, and 6. So I have 1, 2, 3. Okay, this is how we can count less than, and I've already showed you how to count more than. Now, what if the question says, in which region? In which region? In which region means they're asking me for the name of a place. Okay, so if I see this word region, I'm going to look over here. They will ask you questions about the place. Maybe they say, in which region was there an earthquake of magnitude 7.3? Then I will look over here. I see 7.3. This is my region. My answer will be Landers. Or if they say, in which region? Region or regions, maybe there's more than one. In which regions were there earthquakes of magnitude 7.2, for example? My answer will be 2, because I see here there's a region. Okay, remember we're looking at region. So 7.2, 2 regions, Baja and Eureka. So if they ask you in which region, we're going to look over here is our answer. It's going to be a place. So first we will find the number. We will look over here. Once we have the number, we're going to go down here and find our place. And our answer will be the name of a place. Okay, so in which region, name of place. But if they ask me how many, it's going to be a number. Okay, let's look at one last type of question where we are looking at range of numbers. So, sorry about that. How many earthquakes between? So if it says between, that means we're going to look from one number to another number and then count it. So for example, if they tell me between 6.2 and 7.2, so that means the numbers that come between 6.2 and 7.2. So I will look for 6.2, and 6 is not 6.2, so it doesn't count. Here is 6.2, but I will not count it because I want the number between it, not including it. 7.2, 7.2 is over there. Anything bigger than that number, I will not count. Okay, so what am I left with? 1, 2. How many earthquakes between those numbers? I have 2. So my answer is going to be 2. So when they say between, you will find this number, you will find the other number. Anything bigger than this is out. Anything smaller than this is out. The number itself is out. And then you count anything that is left over. Okay, the last type of question. This one is a writing question. So the one before, this one is going to be multiple choice. This one will be writing. And writing, we're going to ask you to arrange something. Arrange means to put it in order. You are going to organize it. How can we organize it? We can organize it from strongest to weakest. Strongest means the big number. Weakest means the small number. So we're going to arrange these earthquakes from the big number to the small number. If they ask you to arrange magnitude, you're going to use the number. They say arrange the earthquake, we're going to put the letter. Okay? So strongest to weakest, we're going to look at our number and put the letters from the strongest to the weakest. My biggest number is 7.3. After 7.3, 6.9. And the smallest number is 6.8. So what letter is 7.3? I have C, then I have A, then I have B. This is from strongest to weakest. But what if they switch the question? And what if they give you, it doesn't matter what numbers are in the table because we cannot memorize those. So remember to learn the method, not the number, okay? What if they ask you to arrange from the weakest to the strongest? Well, I'm just going to look for my small number and then I'm going to look for my big number. My smallest number is 6.8. So that is E. After B comes 6.9, which is A. And the last number, the strongest number, is 7.3, which is C. Okay, so my answer would be EAC. These are my earthquakes from the weakest to the strongest. Let's talk about the forces that act in an earthquake. In an earthquake, the force comes from the side, and we call this side force lateral force. A lateral force acts from the side in an earthquake. So when these forces push from the side, they cause a lot of damage to buildings. Most buildings are made with beams and columns. A beam is this piece that goes across, and a column is this long piece, column for long piece going down. So beams go down, columns go across. And the problem with this is when the lateral force pushes it, it causes it to move to the side and fall down. So what can we do to make this building stronger, to reduce the damage from an earthquake? Well, we can put in F or K shapes. If I put an X or a K shape into my building like this, I call it a bracing. And bracing can make my building stronger to reduce earthquake damage. So again, bracing. Bracing is a shape, a diagonal shape that connects the beam and the column. It will connect the beam to the column. Now let's look at something else that can reduce earthquake damage. And this is called a shear wall. Over here we can see a whole wall over here. So this wall, the entire wall on the outside of the building is made of a whole wall of braced panels. So when we see a stiff wall made of braced panels, we call it a shear wall. And this shear wall will also reduce earthquake damage. And the last thing we're going to look at that can reduce earthquake damage is something called a damper. A damper absorbs energy. So it takes the energy inside of itself and it moves separately from the building. And this also reduces earthquake damage. So it reduces the damage from what? From an earthquake. So our key word to look for is earthquake. It's going to stop earthquake damage. All three of these structures stop earthquake damage. Okay, over here, I've put our keywords to look for. So when we study, we learn the word earthquake, lateral force moves from the side. And what are the three things that make the building strong from earthquakes? Bracing, shear wall, damper. The shear wall, SW, stiff wall. Bracing is a shape that connects the beam and the column. And that beam and column, it can be a K shape or it can be an S shape. Okay. Please give the earthquake questions a try and good luck.